Okay, let's continue our discussion of matrices by looking at something called the determinants. So, the determinant of a matrix, kind of in its most simplest form, is a number, a scalar value that we pull out of different matrices to then use for later purposes. Which sounds a bit weird, but just go with me on this. It's a little bit more abstract than maybe the maths we're used to. Now, the point of a determinant, and first of all, it should be noted that a determinant is written as this. It looks like a modulus, or an absolute value of, A being the matrix in question. Now, in order to find the determinant of a matrix, there's a couple of things we need to do. First of all, we need to establish whether we're working with a 2x2 matrix or a 3x3 matrix. What I mean by that is a 2x2 matrix has 2 rows and 2 columns, and a 3x3 matrix has 3 rows and 3 columns. And there's a slightly different technique to find the determinants of both of them, but overall it is very similar. So let's get started with the 2x2. Now, 2x2s are much easier to work with in general, whether we're finding determinants or inversing or just multiplying really, they are much easier to work with. And that's true when it comes to determinants as well. So I'm going to define my matrix A as 1, 2, 3, 4. Nice, simple. In order to find the determinant of A, I need to do essentially 2 things. First of all, I'm going to start in the top left of my matrix with this 1. And I'm going to draw a line diagonally. So I'm going to find kind of its diagonal counterparts. So I've got 1 and 4. And I'm going to multiply those together. 1 times 4 is 4. Then I'm going to go to the second term in my top row, which is 2. I'm going to do the same thing. I'm going to draw a diagonal from 2, and I'm going to multiply those together. So 2 times by 3. And then all I'm going to do is I'm going to minus these results from one another. So it is top left times bottom right minus top right times bottom left. If you would like that a bit more generally, if I have the matrix A, B, C, D, the determinant of that matrix is AD minus CB. Okay? Nice and simple. So in this case, 4 minus 6, my determinant is minus 2. And with 2x2s, it's nice and simple. It's just that. Now, with 3x3s, it gets a lot more annoying. So, if I come up with a 3x3 matrix, I'll call this one B. Let's go 1, 2, 3, 3, 2, 1, 2, 3, 1. There we go. Some cyclic permutations there. And I want to find the determinant of this. It's not actually the same as what I've just done. I can't take the top, make a lovely diagonal, and then take the next one, make a diagonal, take the next one, make a diagonal, because I'm not actually going to cover all the numbers. If I did that, I'd have those, and those, and I wouldn't be working with the 3 and the 3. So it wouldn't work. So what we do is I start off with my top left value. And the easiest way to visualize this, let's put this down there for a second. The easiest way to visualize this is I'm going to take my top left number and I'm going to cover up the column that it's in. And then I'm going to cover up the row that it's in. And you'll probably look less stupid when you're doing this on a small piece of paper with some pens. And I'm going to see what I've got left. I have got left the matrix 2, 1, 1, or 2, 1, 3, 1. If I cover these two. So covering wherever my 1 is. So what I'm going to do is I'm just going to find the determinant of this matrix. So the determinant of this matrix is 2 times 1 is 2, minus 3, the determinant is minus 1. And then I'm going to multiply it by the number that I crossed out. So multiply it by a 1. And I get just minus 1. And then I'm going to do the exact same thing. But this time with the 2. I'm going to cross out the row that my 2 is in, cross out the column that my 2 is in, and now I've got a 2 by 2 matrix with 3, 1, 2, and 1. If I cross this out, that's the matrix I'm left with. So I've got 3, a 1, a 2, and a 1. And I'm going to find the determinant of that, which is going to be 3 minus 2, which is going to be 1. And then I'm going to, as before, multiply it by the number I crossed out, and I get 2. Then I'm going to do the last thing with the same thing with 3. So I'm going to cover the row and the column with 3. I'm left with this matrix here. I'm going to find the determinant of that. I have 3 times 3 is 9, minus 4. 3 times 3 minus 2 times 2. So 9 minus 4 is 5. And then, once again, I'm going to multiply it by the value that I crossed out. Times by 3 is 15. So, I have 3 different determinants here. Minus 1, 2, and 15. So what do I do with them? Well, the way that I like to think about this is you want to add them up, okay? So we want to do minus 1 plus 2 plus 15. But the weird one, and I define the weird one as the one where we don't have the matrix all in one place. So when I cross out 2, my matrix is spread out on either side of my system. So that to me is the weird one. And the weird one, we want to minus. So we add the other 2 and we take away the weird one, the one that we have to kind of spread out for. The official thing is you take away the determinant made from the middle value of the matrix. So in this case, I'll have minus 1, minus 2, plus 15, which is 12. And that is how to find the determinant of a 3 by 3 matrix.